So this is June 2018, Unit 1. In question 1, what type of formula that shows all the bonds and all the atoms in a molecule? So the formula which represent all the atoms and all the molecules, all the bonds basically and all the atoms in a molecule. Empirical shows the simplest ratio. Molecular represent actual number of atoms but does not show the bond. Structural formula, in a structural formula, we don't represent like we represent the molecule in the particle as a group. In a displayed, we represent all the bonds and all the atoms. So that's why D is the right answer for this. In question 2, the concentration of a potassium ion in human blood can range from 3.5 exponent minus 3 to 5 exponent minus 3. On average, per person has 5 dm cube of a blood, 5 liters of a blood. What is the minimum mass of a potassium ion in average person? So we have the concentration and we have the volume. So when we multiply concentration into volume, that is per dm cube. Like that, and they're asking what is the minimum mass. So minimum mass means we have to take minimum concentration because 3.5 is there and 5 exponent minus 3 is there. So the minimum concentration will give us the minimum mass of potassium ion in the blood. So first we'll get the moles. So moles equal concentration into volume. So the concentration is, we'll take which concentration which give the minimum mass or minimum moles. So that's why we'll take as 3.5 into 10 to the power minus 3 multiplied by the volume of a blood is 5 dm cube. So we multiply this by 5. So 3.5 into 5, that will be 17.5. So 17.5 exponent minus 3 will be the moles present in the blood, moles of potassium ion in the blood. So 3.5 times 5, that is 17.5. So it will be 17.5 into 10 to the power minus 3 moles will be there. And after getting these moles, these are the total number of moles in 5 dm cube. We multiply by molar mass. Molar mass is 39.1. So we have the formula moles equal mass in gram divided by molar mass. So molar mass multiplied by moles, which is 39.1 is the molar mass of potassium. So when we multiply, we'll get 0.684. So B will be the right answer for this. Then what is the number of atoms present in 3.06 dm cube of carbon dioxide at 373 Kelvin? So first, this is a volume. We should get the moles and the molar volume. Normally, molar volume is 24 dm cube, like 1 mole of a gas occupied 24 dm cube. But when the temperature changes, the molar volume also changes. So they give you the molar volume is 30.6. So the formula is equals to moles equal volume is of gas divided by 24 if the molar volume is 24. But now the molar volume is 30.6, so you should divide by 30.6. So volume of a gas is 3.06 divided by molar volume, that is 30.6. So 3.06 divided by 30.6, that is equals to 0.1. So 0.1 moles of carbon dioxide we have. Now, but in the question, we need how many atoms? So one molecule of a carbon dioxide contains 2 oxygen and 1 carbon. So the molecule to atom ratio is 1:3. So if we have 0.1 moles of carbon dioxide, how many moles of atoms will be there? X cross multiply. So we'll get 0.3 moles of the atoms. And this 0.3 moles are there. To get the number of the particles, we'll multiply by Avogadro's number, which is 6 into 10 to the power 23. So 0.3 multiplied by 6 exponent 23. So this will give us 1.8 into 10 to the power 23. So C will be the right answer. First, using the volume, we work out the moles, and using the moles, we find the moles of atom. And from moles of atom, we multiply by Avogadro's number to get the total number of atoms. In question 4, a sample of seawater contains 3.54% of sodium chloride by mass. What is the concentration of sodium chloride in parts per million? So this is a percentage is there. Like if you have 100 gram, this one 3.54 grams will be there. For sodium chloride, and that is a sample of a seawater 3.54. So if you have 100 grams example of seawater, then it means it will have 3.54 grams of sodium chloride. So the formula for concentration in ppm, it is mass of solute. It can be volume of solute depending on the unit in which they give us the question, divided by mass of solvent or the solution into 1 million. That's a formula. So because of percentage, it always refers to 100. So we have, if we have 3.54 grams of sodium chloride, if we have 100 grams of seawater. So the mass of a solute will be 3.54. Mass of the solvent will be 100, and then it is multiplied by 1 million. So when we multiply, like 3.54 multiplied by 10 exponent 6 divided by 100, so it will give us 3.54 into 10 to the power 4. Whenever percentage is given, the denominator, your denominator should be 100, because percentage refers to, like if you have 100 particles or 100 molecules, how many solute molecules are there? This gives us the percentage. In question 5, hot packs and cold packs are used to heat and cool part of the body. What are the signs for standard enthalpy change used for hot packs and cold packs? So basically, hot packs, what they will do, hot packs will release the energy to the surrounding. That's why it make it hot. And what cold packs will do, cold packs will absorb the energy. As they will absorb the energy, the reaction will be, because hot packs used to heat and cold packs used to cool. So cold packs have a tendency to absorb the heat energy, like the chemical reaction which occur in a cold pack will try to absorb energy, and hot pack, the chemical reaction occur which release the heat energy. So for one is the exothermic reaction, another one is endo. Exothermic reactions, enthalpy change will be negative, and endothermic reaction enthalpy change will be positive. So C is the right answer. In question 6, for reaction with the ionic equation. So whenever, this is a definition, whenever 1 mole of a water is formed by a reaction of acid and alkali, like this proton is coming from acid and OH is coming from an alkali. As a result, it formed 1 mole of a water. What we call this, we call that as a enthalpy change of neutralization. Atomization means when we produce from a molecule or from element in a solid state or liquid, we produce a gaseous, we produce atom in a gaseous state, we call that as atomization. Combustion means when we burn 1 mole of a fuel. Formation when elements form a compound, and neutralization when 1 mole of a water is formed from the reaction between acid and alkali. That's known as enthalpy change of neutralization. An excess of zinc powder is added to a solution of a copper 2 sulfate. The maximum change in temperature of a solution is measured. The energy transfer in joule is equal to mass into specific heat capacity into temperature change. In this calculation, it is usually assumed, what we assume, the mass is equal to the mass of zinc added. No, that mass is not the mass of zinc added. It is the mass of a solution. And we consider that the density of a solution is 1 gram per centimeter cube. So its volume will be same as the mass. Mass is equals to volume of copper sulfate solution. That is true because we consider that the density of the solution is 1 gram per centimeter cube. So what is the volume of the solution? Like if volume is 30 cm cube, same will be the mass of the solution. So this mass is refers to mass of the solution, or we can also say volume of the solution. That's our assumption is that the density of a solution which we are using is 1 gram per centimeter cube. In question 8, 10 cm cube of 1 mole per dm cube nitric acid is mixed with 20 cm cube 1 mole per dm cube sodium hydroxide, and the temperature change is delta theta or delta T. If a reaction is repeated using 20 cm cube of nitric acid and 20 cm cube of sodium hydroxide. First, when you check the first reaction, how many moles? 10 divided by 1000, because concentration into volume, but the volume should be in dm cube. So it will be 10 divided by 1000. So in the first reaction, we are using 0.01 moles of nitric acid, and we are using 0.02 moles of sodium hydroxide. So which is a limiting reagent? Nitric acid is a limiting reagent. So the change in the temperature is due to the nitric acid because it used up the temperature change or energy release is due to the limiting reagent. Then the second reaction, we use 20 cm cube, so and 1 mole per dm cube, so 0.02 moles, and here also 0. Now the second reaction, both will be used up completely. The question is, what is the temperature rise or temperature change? So how to solve this question? You have the formula E equals Cm delta T. C is a specific heat which does not change, so E divided by M is equals to delta T. Means the energy release is directly proportional to temperature change, like cause a greater change in temperature, and the mass of a solution is inversely proportional to temperature change. Like if we have a volume of a solution is inversely proportional to temperature change. If we have a large volume of a solution or a mixture, the temperature change will be small. So when first it was 0.1, the temperature change was delta T. Now the limiting reagent is 0.2. So if the number of moles are double, what happened to temperature change? So the temperature change should be double due to the change in the number of moles. Now what about the volume of the solution? First it is 10. Now for like the total volume 10 plus 20, so total volume was 30. So first total volume or total mass is 30 and the temperature change is delta T. Now what happened? The total volume of a solution, this is 20 plus 20, so made 40. So how much it increased? So it is increased by 1.33 because like 30 multiplied by 1.33 will give us about 40. So if this increased by 1.33, because the mass and temperature change are inverse, so this will decrease by 1.33. So due to change in the moles, it should be multiplied by 2, and due to change in the mass or the volume of solution, it should be divided by 1.33. So when we simplify, like 2 divided by 1.33, that is about 1.5. So we can say that delta T is equals to 1.5. Like compared to the first, it will be 1.5 times the original value. So B will be the right answer for this. This one is according to old specification, so that's why enthalpy change questions are in unit 1. But according to new specification, enthalpy change question will be in unit 2. Which of the following equations shows the process occurring when second ionization energy of magnesium is measured? So first ionization energy, when we remove one electron, and ionization energy means energy needed to remove electron. That is first. If second ionization means we remove the second electron, one electron is already removed, and now we are removing the second electron. So here this cannot be because we are removing two electrons same time. But in the question, only second ionization, not first and second. So that's why D is the right answer. Negative means loss of electron or removal of electron, or I can also write like magnesium is +1. It changes into magnesium +2 ion by loss of electron. So that is the same thing. This is a graph which shows a variation of ionization energy when we move across the period. So sodium, magnesium, then aluminum, silicon, phosphorus. The graph 2 shows a variation of successive ionization energy of sodium. What quantities were plotted on the y-axis to produce this graph? So whenever plotting a graph, because they have a greater, when you have a greater value, like large values are there, whenever we have a large value, so to reduce the scale, we always use logarithm. In the first one, because they don't have too much difference between them, like sodium, magnesium, successive ionization, but for an atom, like example, when we are removing the electron, they will have a large difference in ionization. Maybe the first value might be 300, the second value might be 10,000, the third value might be 11,000, and even this value might be 23,000. So it will be difficult to plot them 23,000. So it will be difficult to plot them on the same scale. That's why whenever we are plotting a graph for successive ionization energy of elements, we always use log of ionization energy, because the variation is too much. Like there's a big difference between the smallest and the largest value in the combination. That's why we use a logarithm scale, which reduces the interval or reduces the values, so we can plot them on the same scale. But the first one, which was about the period, so they have successive, because elements, example, if this is 300, this will be might be 350, this might be 280, this might be 400, example, this might be 510. So successive ionization energies, consecutive ionization energy for element in the same period, they are in the same order, so it's easy to plot them by using their same values. So this one, for the first graph, we take the actual values, actual ionization, but the second graph we took log. So A should be the right answer, because for first ionization, successive elements. So when we are talking about period, because the values are comparable, we can plot them on the same scale. But when for same element, the ionization like first, second, third, fourth, it will be difficult as the variation is too much. That's why we took a log scale, log of the value, to reduce the scale size. What is the quantum? What is the number of quantum shells in sodium suggested by the graph 2? So how many shells are there in sodium? How you identify? Look, sodium, you can work out using a periodic table, or from this you can easily identify. Like this is the last shell, and these elements are in second last shell, and these are elements are, so this is actually the first shell, the second, and the third. So there are 3 shells in sodium, and the configuration is 2, 8, and 1. So it is of, so we can say that it will have 3 shells. So B will be the right answer. The smallest ion which is isoelectronic with sodium is to be isoelectronic means it should have the same number of electrons. Hydrogen having 1 electron, but hydrogen -1, 2 electrons. So it is not isoelectronic. Nitrogen 7 electron, but -3, so 10 electron. Oxygen 8 electron but minus 2, so 10 electron. Fluorine 9 electron but minus 1, so it took 10. Then we check the proton number. Nitrogen will have 7 protons attracting 10 electrons. Here 8 protons attracting 10 electron, and fluorine 9 protons are attracting 10 electron. So they will have more attraction towards the nucleus. That's why fluoride ion will be smaller in size as compared to oxide ions, and oxide ions are smaller in size compared to nitride ions. So the question is, which is the smallest isoelectronic? Isoelectronic means same electrons as sodium, and sodium plus 1 means 10 electrons are there. Because sodium atom is 11, sodium ion is 10 electrons. So D will be the right answer for this. The electronic configuration of a metal ion with a charge 3 plus could be, means group 3 element, because 3 plus means it should be group 3 element, and group 3 element so it should lose 3 electrons. And the second thing, whenever ions are formed, they should have a stable shell or orbit or subshell, we can say. So how stable subshell will be there? Like S should, when ions are formed, loss of electron occurs. So S should be 2 electron, P 6 electron, D 10 electron, and F 14 electrons. So we have to check this. These ions like 3s1, it is not correct. Why? Because ion can form, but it won't be stable. Whenever atoms are losing electron, they turn into ion and they gain stability. How they gain stability? By completing the orbitals. So here 3s1 is there, it means it is half filled, not too much stable. 3p1 again, not too stable. 3p3 not too, it is stable but not too stable. But when you check for A, because the last shell 2p or orbital, the last orbit or a subshell 2p6, that is complete. So that's why A is the right answer. Why B, C, and D are not correct options? Because it shows that the shells are still like not completely filled. Either it will be stable if this electron is lost from the like 3s, or there should be no electron here, or there should be no electron here, then it will be stable. In question 13, 2 pieces of filter papers are soaked in water which are attached to microscope slides. A few crystals of potassium manganate. So potassium manganate, what ions it contains? It contains potassium and it contains manganate ion. The manganate ion is purple in color, so manganate ion will be attracted towards the anode and potassium ion cathode. But it is aqueous, so hydrogen will be there because positive ion, less reactive positive ion tend to move. But we cannot see even hydrogen or potassium ion move. We don't see any color change. But only for purple color movement is there towards the anode, but not towards the cathode. A few crystals of blue copper 2 sulfate. So copper 2 sulfate, it contains copper 2 ion and sulfate ion. So sulfate or hydroxide ion does not, like, are colorless. Only copper ion is there that will move towards, it's a positive ion, so it will move towards the negative. Both are connected to a DC supply. Which electrode do the color of a filter paper move towards? Filter paper with the potassium. So because it contains potassium manganate, and manganate ion is negative ion, so it is attracted towards the positive. And copper ion is a positive ion, so it is attracted towards the negative. So blue color will move towards the negative and the purple color will move towards the positive electrode. In question 14, the similarities between the metallic element and ionic compound is that both are held together by a force of attraction between the positive and the negative ions. Look, positive and negative ions are present in ionic substance, but there are no positive and negative ions. There are positive ions and the delocalized electrons are there in metals. So statement is not correct. They're held together by electrostatic forces. That is true. Electrostatic force is refers to force between the charges. Any kind of charge, the force between them is called electrostatic force. Consists of a lattice of only positive ion. That is wrong because metals only have a lattice of a positive ion. And consists of a giant structure of atoms. That is wrong. They consist of a giant structure of ions. And for ionic compound, it is unlike charges are there, unlike ions. And for metals, they have a lattice of a positive ion. Then question 15. In what state do sodium and sodium chloride conduct electricity? Sodium is a metal and metal can conduct electricity in all the state, like even it is a solid or a liquid or more melted state, it will conduct. But sodium chloride is an ionic compound. An ionic compound cannot conduct electricity in solid. They can only conduct in molten or aqueous. So A will be the right answer for this. 4 dot and cross diagrams are shown. Which diagrams are correct? So you have to identify according to sharing. So this one, all like carbon share 4, hydrogen share 1, they are stable. Oxygen belongs to group 6. So as it belongs to group 6, it will share 2. But what is missing here? The unshared electron, they did not draw. Even sharing is correct, but they did not draw the unshared electron. So that's why X is not correct. Then why carbon share 4, 1, 2, 3, and 4, and unshared, there is no unshared electron, so that's right. And iodine took extra 7 belongs to iodine, and 1 it took. So W, Y, and Z are correct. So B will be the right answer. Why not X? Because X should have lone pair on oxygen, but there is no lone pair drawn on oxygen. So B is the right answer. In question 17, which molecule contains the greatest number of pi bond? Remember, like if there's a double bond, one is sigma, one is pi. If there's a triple bond, one is sigma and 2 will be the pi. So carbon dioxide, when I draw the structure of CO2 or carbon dioxide, so this will be sigma, this will be pi. This will be sigma, this will be pi. So 2 pi bonds are there. When I draw ethene C2H4, single bond is always sigma. So single I don't have to consider. The one will be sigma, one will be pi. So this contain only 1 pi. Ethane, all are single bonds. So there is no sigma bond, there is no pi bond, all are sigma. And C2H4, like 4 carbon atoms, this will have 2 hydrogen, this will have 1 hydrogen, 2 hydrogen, and 3 hydrogens. So only this bond, one will be sigma, another one, rest all are sigma, but in these two, the double bond, one is sigma, one is pi. So this also contains 1. So the answer is carbon dioxide, which contains the maximum number of sigma bonds. Sigma bonds are formed by complete overlapping of the orbitals. The diagram shows the shape and the relative size of 4 of atomic orbitals in the magnesium. Which diagram represent S? 2S. First thing, so different shapes are there. So this is P because dumbbell. So it cannot be an answer. We are left with either E can be answered, F can be answered, or G can be an answer. But they are different in size. So what is S are spherical. So this will be 1S. Then bigger than 1S will be 2S, and then bigger than 2S will be 3S. So the question is which one is representing 2S? So it means F is representing our 2S. As they already mentioned, These are the orbitals which are present in magnesium. So the only difference between like 1s, 2s, 3s, 4s is their shape is identical, only the size is different. The number of structural isomers for C6H14 is so we have 6 carbon atoms. First, they will be in a straight chain. Then there will be 5 will be there. Then one branch with the first one. Then 5 will be there. One branch with the second, like the third one, sorry. This is second one and this third. I cannot put a branch on the right hand side because it will be similar to that of first. Then there will be 4. They will have 2 branches. One is for a second one, another one with the third one. Or they might have branch both attached to the same carbon. So 1, 2, 3, 4, 5. And then 1, 2, 3. So when I try to draw any other structure like making a 3 and then, so it does not make difference, it will be same. So how many possible isomers are there? So it contains possible 5 structural isomers.